Hello students, today we are going to discuss the second numerical of virtual work method. Question is written as find the vertical displacement at the free end of the cantilever beam. Now here a cantilever beam ABC is shown having point load of 20 kN at B and at C. The moment of inertia for span AB will be equals to 2I and for BC it will be equals to I, and the span length is same for both these spans, that is 2 meter and 2 meter. Now for computing the vertical displacement of free end, that is C, we need to find the capital M value due to external loading on the structure as well as the small m value due to unit load at C. Now we had just made a table here in which we had written portion, span CB and span BA. Now first of all we need to take the origin for span CB and BA. Now the origin for CB will be equals to C and for BA it will be equals to B. Now the limit for both this span is 0 to 2 meters, so we just write here 0 to 2. Now for finding the capital M value in the span BC, we had just made a section XX here whose distance from C is x meter. Now the moment which will be acting on this XX axis will be equals to minus 20 into x due to this point load. Now here the negative sign is because of hogging bending moment, so we had just write here minus 20 into x. Now for span BA we need to consider a section here, that is XX, whose distance from B end is x meter. Okay. Now the moment that will be acting on this XX section will be equals to minus 20 into x plus 2 due to this point load minus 20 into x due to this point load. So we had just taken the minus sign common and we had just write the value, that is minus 20 into 2 plus x plus 20x. Okay. Now for finding the small m value we need to apply a unit load at C. Now after applying the unit load at C we need to find the small m value, for which we need to take a section XX here whose distance from C is x meter. Now the moment that will be acting on this XX axis will be equals to minus 1 into x. Minus sign is because of hogging bending moment, so we had just write here minus x. Now for span BA we need to consider a section here, that is XX, whose distance is x meter from B, and the moment that will be acting on this x will be equals to minus 1 into x plus 2 due to this unit load. So we had just write the value, that is minus x plus 2. Now we had just write the values of moment of inertia for CB as I and for BA as 2I. Now for finding the deflection by the virtual work method we need to put all this value in the expression, that is delta equals to 0 to L integration mm upon EI into dx. Now after putting the value we will get expression as integration 0 to 2 minus 20x into minus x dx upon EI. Here minus 20x is the value of capital M and minus x is the value of small m. Now we had taken the another expression for another span, that is integration 0 to 2 in bracket 20 into 2 plus x plus 20x into x plus 2. This value is capital M and this value is small m divided by E into 2I, because the moment of inertia for this span is 2I into dx. Now after solving this we will get delta C as 306.67 upon EI, that is the vertical displacement of the free end of the cantilever beam in downward direction. So we had computed the vertical deflection of the free end of the cantilever beam as 306.67 upon EI in the downward direction. So students, we had completely solved this numerical. Thank you very much.